Hello friends, welcome back to the channel. So regarding that design information and how do we validate to design information in the RTL to GDS2 flow, that I will discuss is. And in my previous video I talked about the parser view when the functional specification for a particular chip is basically first converted to the RTL language, and then some parser view is being created with the number of input ports, output ports, which kind of logics, those can be summarized by the parser. So any kind of HDL parser can summarize this kind of information. That is the parser view. Now today I will talk about the synthesis view, which is basically the when we start with the RTL, you run some synthesis tool and it generates some logic. So synthesis is nothing but the nearer abstraction to the actual chip, where whatever the logic you write in terms of description of hardware description language, that is actually mapped to the library. For example, if you have written some syntax to construct a flop, to construct a latch, this kind of logic can be actually mapped to the DFF or latch kind of library cells in the synthesis. So that means that synthesis is something, after the synthesis you get more detailed information about the design, which is not probably available in the RTL level views or the parser level views. So parser level views is kind of abstraction which gives some interface kind of activity, where you know that how many design input or output ports or in-out ports are there, and there is some logic inside this always block. But in the after the synthesis, you know that in detail how many logics, how many library cells, how many standard cells, how many nets, all these things are used part of converting the RTL to the synthesized netlist. This is called the synthesis output, is called the synthesized netlist. So now the interesting thing is that you need to do a check between the parser view and the synthesis view. Why? It can happen that if by any error the synthesis netlist contains fewer number of ports than you actually started within the RTL view, that can lead to a devastation and you need to respin the chip once again. So then I will talk about A and B. A is basically the parser view and B is basically the synthesis view. So I will compare these two. May not be, it can be apple to apple comparison, because in the parser view you do not know how many nets are needed to actually map this circuit or how many standard cells are needed. So at least what you can do the interface checking, that means the number of input output ports and some other basic things, some constant value. So in the parser view also you can write some nets as constant net. So those constant net, if it is used in the circuit, that will be part of the synthesis view, but if it is not used, that means it will be eliminated. And those kind of things will come when we compare these two views, and you can validate that okay, this kind of things is not required, that means it is not mapped to the synthesis netlist, synthesized netlist. But this kind of things are basically eternal, and something like in-out port or input port or any kind of interface, that is also present in the synthesized netlist. So basically the apple comparison is not required, but at least from the top level the abstract comparison between these two views is utmost important to propagate the design methodologies beyond synthesis. So it's basically synthesis view is basically the first level of abstraction towards the chip manufacturing or chip fabrications. So today's video is basically all about how do you compare, how do you generate the synthesis netlist. You can run any kind of design automation tools. You can run these tools to generate the synthesis netlist, and then you can check that the RTL views and synthesis views are matching with each other at the abstract level. But not the least, I would like to share that I have published a book, Semiconductor for All, which basically caters all these semiconductor innovations and the technologies, and also its application on electronic design automation and other fields like robotics. And also I have covered the manufacturing of semiconductor technologies. So if you are interested about semiconductor, if you are interested about artificial intelligence, I would highly recommend that you purchase this book from Amazon. This is the Kindle version. I will provide the link in the description of this video. And last but not the least, before signing off, I would like to tell that if you have any feedback about this video and about these topics that I have to discuss today, you can drop comments and I will try to answer those comments. So with that, Subhasish Chakraborti signing off.